Let's be real. You probably use it every single day. But have you ever stopped to think about what's actually happening when you connect your phone to your headphones? That little connection symbol? It's not magic. It is an absolute marvel of engineering, and we are about to pull back the curtain and see exactly how it all works. I mean, seriously, think about it for a second. You hit play, and just like that, music is in your ears. There are no wires, there's no physical connection. So how does that music, that signal, make the leap through nothing but air? And here's where it gets wild. To really grasp what's going on, you have to appreciate the sheer amount of data we're talking about. For your music to sound even halfway decent, your phone is beaming a million ones and zeros to your headphones every single second. How on earth does all that information get there without just turning into a garbled mess?
Well, the best way to understand this is to start with something we all know, something super simple, a traffic light.
You know, a traffic light is basically just a simple communication device, right? It uses two different colors, which are really just different wavelengths of light, to send a very clear message. You've got red, which has a longer wavelength, and that means stop. And you've got green, with a shorter wavelength, meaning go. Two different waves, two very clear instructions. Simple.
Okay, so stick with me here. We're going to take that exact same idea and just apply it to Bluetooth. The only difference is we're moving from a part of the electromagnetic spectrum we can see, visible light, to a part we can't see, radio waves.
The comparison is a perfect one-to-one match. Just like the traffic light uses two different colors, Bluetooth uses two slightly different radio wavelengths to get its message across. One specific wavelength represents a digital 0, and a slightly different one represents a 1. So by flipping between these two invisible colors at an insane speed, your phone is literally speaking the binary language of ones and zeros.
All right, so sending ones and zeros with waves sounds pretty straightforward, right? Well, there's a huge catch. See, Bluetooth isn't having this conversation in an empty, quiet room. Oh no, it's trying to have a nice, clear chat in the middle of a loud, super crowded party. The specific radio frequency that Bluetooth uses is called the 2.4 gigahertz band, and you can think of this band as a big public highway up in the sky, and it's totally open for anyone to use. And as it turns out, a lot of our gadgets want to use this same highway.
And just look at how busy this highway is. It's not just other Bluetooth devices we're talking about. Your home's Wi-Fi network is on there. Even your microwave oven is blasting out noise in the exact same frequency range every time you heat up your coffee. So with all that shouting and interference, how does your music possibly get through cleanly?
This is where the real genius of Bluetooth engineering shines. To cut through all that chaos, engineers came up with this brilliant two-part strategy. First, organize the data into smart little packets, and then move around incredibly fast.
So first things first, the data isn't just blasted out there in one long, messy stream of ones and zeros. Nope. Instead, it's all broken up and bundled into these little things called data packets. The absolute best way to think about this is like sending a letter. You don't just yell words into a mailbox, you write them down, you put them in an envelope, and you put a very specific address on the front.
And each of these digital letters or packets has three crucial parts. First up is the access code. That's the address on the envelope that makes sure it only goes to your headphones. Then there's the header, which is like the instructions, saying what's inside. And finally, you have the payload. That's the good stuff, the actual ones and zeros of your music. So, putting the data in these neat little packages definitely helps, but that's only half the solution. The other half is, well, it's even more clever. To avoid getting stuck in a noisy spot on that wireless highway, Bluetooth devices don't just stay in one lane. They are constantly, and I mean constantly, channel surfing. See, within that big, crowded 2.4 gigahertz highway, engineers sliced it up into 79 different, smaller lanes, or channels. This gives your devices a whole bunch of options to try and find a clear path to talk to each other.
And this is the part that just blows my mind. Your phone and headphones don't just switch channels every now and then. They are hopping between those 79 channels 1,600 times. Every single second. It is an unbelievably fast, perfectly coordinated dance that's always happening to find a clear signal. And this crazy fast hopping is what makes the whole system so strong. If one channel is suddenly noisy because someone turned on the microwave, who cares? Your devices just instantly jump to another clear one. It stops different Bluetooth gadgets from stepping on each other's toes. And here's a cool bonus. Because the hopping pattern is like a secret handshake only your paired devices know, it makes the connection incredibly secure and private. So when you put all those pieces together, the smart packets and that lightning-fast hopping, you start to see this beautiful hidden architecture that makes our entire wireless world possible. It's just a system built on really elegant solutions to some really complex problems.
You know, the team over at Branch Education really said it perfectly. There is just an immense amount of engineering crammed into these tiny little devices. We're talking about specialized chips that are constantly filtering out noise, checking for data errors, and orchestrating that incredible high-speed frequency hopping dance. And it's all completely invisible to us.
So here's the bottom line. That seamless connection you get every day isn't magic at all. It's a perfectly executed symphony. It's the combination of neatly addressed data packets and the hyper-fast agility of frequency hopping, all working together in perfect harmony to deliver a clear, reliable signal right through the middle of a very noisy world. So the next time you pop in your wireless headphones and hit play, you'll know about the incredible high-speed ballet that's happening behind the scenes just to bring you that sound. It kind of makes you wonder, doesn't it? What other invisible systems are all around us, powering our world, just waiting to be explained?